Hello students, welcome to the classroom point. In this session, we shall discuss the half-life period of the first order reaction. Let us try to know what is the definition of the half-life period first. It is the time required to convert half of the initial concentration of the reactant to the product. Whatever the time we need to convert the reactant into product of to its half value, it is called as the uh, half-life of the reaction. Half-life period definition. It is usually represented by the denoted by the T half. Now let us take the first order rate equation for rate constant formula K equals to it is 2.303 divided by T into log initial concentration A divided by final concentration A minus X. You can take other forms also like this. K equals to 2.303 by T into log concentration of A naught divided by concentration of A, or you can take many other forms are there. K equals to 2.303 by T into log initial concentration C naught by final concentration Ct, or in this place you can take the R naught, and in this place you can take the R. It is up to us. So whatever it may be, the meaning is same. Since here we said half-life period, so that time becomes a T half now, and final concentration is nothing but the half of the initial concentration. So okay, so final concentration means A minus X. Whatever the final concentration is there, this A minus X is nothing but the A by 2 value. Because initial concentration is A, so here it becomes A by 2. In this case, you will take the A naught by 2. In this case, you will take the C naught by 2. If you take this one, it becomes the R naught by 2. Okay, let us try to substitute these two forms in this equation. We shall get now K equals to 2.303 by T half, because T becomes T half, log A divided by A by 2. Now, here A get cancels and the denominator comes to the numerator. So finally we can write T half equals to 2.303 by K into log 2. Log 2 value is 0.3010. This whole value is equals to 0.3010. So now T half equals to 2.303 into 0.3010 divided by K, and finally here we'll get the uh, answer value approximately, not approximately, exactly T half is equals to 0.693 divided by K. This is the half-life period of the first order reaction rate. Here one thing we must understand, that is there is no concentration term in this final formula. Hence, half-life period of the first order reaction do not depend on the initial concentration. Whatever the initial concentration it may be, T half remains constant. This is completely constant. Example, let us take some 100 grams of A converted to the 50 grams of A for this conversion, because half of the reactant converted to the product. So remain final concentration, the half of the initial concentration. The T half is equals to, imagine, 10 seconds. Even if you take 200 grams of A to make it into 100 grams, T half remains same, that is 10 seconds. Even if you take 500 grams of A to convert this one into the 250 grams of A, again half of the initial value. Do not compare these two. Only initial value, final value we need to compare, that and the time. So here again T half remains same, that is 10 seconds. Means within the 10 seconds of the time of that particular reactant of a first order reaction becomes half of to its initial value for this particular type of the reaction. So that is called as the T half, and T half is independent of the initial concentration. Here, whatever the initial concentration quantity it may be, to make this initial concentration into half of its initial value, T half remains same, whatever the T half is required. But in zero order reaction, T half is directly proportional to the initial concentration. So T half is directly proportional to the initial concentration. There we discussed for zero order. So for such type of the reactions, when the initial concentration increases, the T half value also increases. But in the case of the first order, it will not happen. This is about the half-life period of the first order reaction. Hope you all understood. If you like this one, please do not forget to subscribe. Thank you.